Hello, everybody. I hope this video is finding you well. Uh, I apologize for the late upload today, but I was having some technical difficulties with my microphone. But with all that being said, I'm here to help solve the molarity equation along with the mole fraction, as well as explain why any of this even matters in nursing. So, with all that being said, let's get started. Okay, so first part of our discussion, we're asked to find the molarity of phosphoric acid. Now, the first thing that sticks out is that phosphoric acid solution is 85.5% by mass, and usually that means we got another mass percentage calculation to do, but thankfully we can convert it into the fraction 85.5 grams of phosphoric acid over 100 grams of a solution. So we would take both numbers, first the numerator, 85.5, and divide that by the molar mass of phosphoric acid, which is 98. We would end up getting 0.872 moles of phosphoric acid. And with the 100 grams of solution, we would convert that into liters using the given density of 1.69 grams over milliliters. In doing so, we would get 59.2 milliliters. However, since it wants us to convert it to liters, we would just divide 59.2 milliliters by 1,000, and we would end up getting 0.0592 liters of solution. That way, we can finally plug in our units into the molarity equation, which is 0.872 moles of phosphoric acid over 0.0592 liters of solution, which gives us a molarity of 14.7. All right, moving on to the mole fraction of urea, we have to take things step by step. So as we said earlier, we're going to need the molar mass of both urea and methanol. So we're going to divide 5.6 grams of urea, divide that by the molar mass of the substance, and we would get 0.093 moles. Getting the molar mass of methanol, we get 32.05. So divide the given 30.1 grams by the 32.05 grams per mole, and we would get 0.939 moles of methanol. And when we take the total moles of the mixture, we would then get 1.032 moles. So then we would take the moles of the solute and divide that by the total moles of the solution to get a mole fraction of 0.090. Now, this brings us on to our million-dollar question, which is, why does any of this matter? Why is it so important to understand this? Why did we have to do all this work? Well, if we remember, molarity is the measure of the concentration of one substance in moles in an entire mixture. And if we remember from our aspirin synthesis lab, phosphoric acid was used as our catalyst. The 10 milliliter drops, we didn't need that much, all that good stuff. If we could see here as well, the chemical reaction, we see that phosphoric acid is 85% by mass. Now, knowing the concentration level for substances will help us determine if a substance can be pure or synthesized purely or impurely, as we judged each other's the color in iron 3 chloride. But that's the end of my presentation. Let me know your thoughts. If you're confused about one of my steps, or if you wanted to correct me on anything, please let me know. I want to hear everybody's thoughts. But thank you again so much, Dr. Pasha, for letting me record a video for this lecture. And yes, have a good day, and I will see you in class next week.